Imagine an aircraft so massive, it makes a Boeing 747 look like a private jet. A plane with 10 times the volume of a 777. Now imagine that same plane, the largest ever built, landing not at Heathrow or JFK, but on a 1,800-meter strip of packed dirt in the middle of nowhere. It sounds like an engineering fever dream, or perhaps a recipe for a multi-billion-dollar disaster. But in 2026, this is the reality of the Radia WindRunner. For decades, aviation has followed a simple rule. Bigger planes need bigger, stronger, more expensive runways. But as we stand at the dawn of a new energy era, that rule is being shattered. The WindRunner doesn't just challenge our understanding of aerodynamics. It's being built to solve a specific, massive problem that's currently holding the entire green energy revolution hostage. Today, we go inside the hangar to see how the world's largest aircraft is designed to do the impossible: land a Titan on a trail of dust. To understand the plane, you have to understand the blade. As the world pivots toward renewable energy, wind turbines are getting bigger, much bigger. Engineers have realized that longer blades capture exponentially more energy, with some now exceeding 100 meters in length. But there's a problem. A 100-meter blade can't turn a corner on a standard highway. It can't fit through most tunnels, and it certainly can't pass under a low bridge. We've reached a logistical ceiling. We can build these massive blades in factories, but we can't get them to the windy, inland plains where they're needed most. This is what Radia calls the green energy bottleneck. Currently, companies have to resort to multimodal transport, slowly moving parts by ship, then rail, then specialized trucks that require roads to be widened and signs to be torn down. It's expensive, it's slow, and it's limited. Radia's solution was radical. Why not just fly them? But there was a catch. Most wind farm sites are hundreds of miles from a commercial airport. Building a multi-million-dollar paved runway just to deliver turbine parts would defeat the whole purpose. The WindRunner had to be a giant that could live like a pioneer. Most cargo planes are designed for weight. They carry tanks, engines, and heavy machinery. But wind turbine blades are surprisingly light for their size. They're just incredibly bulky. This allowed Radia to make a unique design choice. They prioritized volume over weight. The WindRunner boasts a staggering 6,800 cubic meters of usable cargo space. To put that in perspective, you could fit a 3-story house inside the cargo hold with room to spare. But how does it land on a dirt strip without sinking or snapping in half? The secret lies in its landing gear and its infrastructure-light philosophy. Unlike a standard airliner that focuses all its weight on a few points, the WindRunner uses specialized, high-flotation tires and a distribution system designed for semi-prepared or unpaved runways. Because it's carrying light, cargo, massive blades rather than solid lead, the plane doesn't require the massive reinforced concrete of a major international hub. It can land on a strip just 1,800 meters long. That's about the length of a secondary regional runway, but the WindRunner can do it on dirt. Speed is the second half of the equation. If it takes 3 days to unload the world's largest plane, the economics fail. That's why Radia implemented a roll-on, roll-off system. The entire nose of the aircraft swings upward. Because the cargo floor is relatively low to the ground, standard ground equipment can drive those 100-meter blades directly into the fuselage. No massive cranes, no complex rigging, and most importantly, no disassembly required. But wait, building a giant, experimental aircraft is usually a shortcut to bankruptcy. Just ask the makers of the Spruce Goose. Radia is playing it smart. Instead of inventing new, unproven engines or radical carbon fiber composites that would take decades to certify, they are using proven, certified components and a conventional aluminum fuselage. They are focusing the innovation where it matters, the scale and the landing capability. Radia isn't just selling a plane, they are planning a transport-as-a-service model. They will operate the fleet themselves, providing flexible capacity to energy companies, governments, and even humanitarian organizations. While green energy is the primary mission, the military has already taken notice. In a single flight, the WindRunner could transport 6 assembled CH-47 Chinook helicopters, 4 F-16s, or even 4 F-35CS. Usually, these aircraft have to be painstakingly taken apart, stuffed into a C-5 or C-17, and then reassembled at the destination. The WindRunner could deliver them ready to fly, landing them directly at a forward operating base with a dirt runway. From delivering massive satellites and rockets to dropping off entire mobile hospitals in disaster zones where the local airport has been destroyed, the WindRunner's ability to bypass infrastructure makes it a strategic asset unlike anything we've ever seen. So when do we see this titan in the sky? As of early 2026, Radia is moving through detailed design and supplier integration, with partners like Lakecure for wiring and Sterling Dynamics for flight controls. The industrial ecosystem is already taking shape. The target, first flight by the end of the decade. The WindRunner is a reminder that sometimes, to move forward, we don't need to fly faster, we just need to think bigger. By solving the dirt runway puzzle, this aircraft might just be the key to unlocking the clean energy future we've been promised. But is the WindRunner the only revolution in the sky? In our next episode, we look at the new law that just killed the dream of pilotless cockpits and why Airbus is suddenly scrambling to redesign its future. Don't forget to like and subscribe to catch the rest of our Aviation 2026 series.